Hello guys, today we're going to be taking notes on our next section or sections, which are 3.3 to 3.5. They all focus on solving equations. In the book, it breaks it up with addition and subtraction, multiplication, division, and 1 and 2 step. But we're going to do it all together just because it's the same steps in the same process. So make sure you are taking notes along with this just because this is going to cover a lot of the material that we're going over the next couple weeks. And of course, it's going to help be a foundation of your math education. Solving equations is one of those really big topics. Okay, so as usual, make sure you are taking notes along with this video. And today we're going to be going through two things. We're going to discuss the process of solving equations, and then we're going to complete various examples. So make sure you are writing down both the process and, of course, copying down all of the examples. And then you can star or highlight any questions you have so we can go over those together in the live session. All right, so let's get started with the solving equations process. So I made a little process chart here. I will have an expanded version for you guys posted online as well. But here's the process chart. We're going to use the same process as we walk through each of these examples. So if you need to pause the video for more time to write this down, go ahead and do that. And we will walk through what those are. So the very first thing to do is we want to see what operations are occurring in the problem. So this says to highlight it and determine what the inverse operation is. So just so you guys know, let's identify what inverse operations are. So for example, when we have addition, the inverse is subtraction and vice versa. So the inverse of subtraction would be an addition. Those are how we undo them. And then the inverse of multiplication is division and also vice versa. Those undo each other. And you'll see more so how that works once we move on and do examples with them. But basically, if equation said x minus 2 equals 4, since that says minus 2, it shows subtraction. We would do the opposite by adding 2 to both sides in order to isolate the variable. All right, so first highlight the operation in the problem, determine what the inverse is. Remember, I put the inverse right down here. After that, we will use inverse or opposite operations. So this is just another word to help you understand what inverse is. It's the opposite operation, and our whole goal is to get the variable by itself. So we want to isolate the variable. That's the big idea, isolate the variable. Don't forget to do this on both sides to balance the equation. Once again, once we see this in action, you might be able to understand it a little bit better, but make sure you're writing this down now. And then the very last part, the really great part about equations, is we can always check to see if our answer is right by plugging in the value that we determined the variable equals and seeing if it actually makes the statement true. Of course, if it did not make the statement true, we know that we made a mistake somewhere and that we need to go back and refine the process. Okay, so get all of this copied down and we will go ahead and move on to some examples. All right, so I put a little process chart over here on the side just in case you need help with knowing what to do. But remember, the very first step was to highlight what operation is going on here. And in this case, it's addition. And of course, the inverse of that is subtraction. So that means we have to subtract. Okay, so I'm going to rewrite this equation. X plus 4 equals negative 14. So our whole goal is to isolate the variable. We want to get this x by itself. So we're going to have to do the opposite operation or inverse in order to get that x by itself. And this is why we are going to subtract 4 from each side, because we want to get the x by itself. So when I do 4 minus 4, the way I set these up is I always cross it out just so you know that cancels. Of course, positive 4 minus 4 is going to give us 0. Those will always cancel anytime you're doing the opposite operations correctly. And then we have to do it to both sides to balance the equation. So now we have to subtract 4 from this side as well. So we're subtracting 4 from negative 14. Remember, those are both negative. So in this case, we're going to add and keep the sign. So this is going to give us negative 18. And we get x equals negative 18. So it seems like we're all done, but remember, we want to use our last step and go ahead and check this in order to make sure it's correct, because it's easy to make a simple mistake. So we're just going to plug in the negative 18 in place of the x and then see if this is true. So negative 18 plus 4 equals negative 14. So when we do negative 18 plus 4, remember those are different signs, so we subtract. 18 minus 4 gives us 14, and we'll keep the bigger sign, which is the negative. So we see negative 14 equals negative 14, and that's true. Those do equal each other, so we know that's correct. All right, there is one example. Let's move on and complete some more. All right, so now we have c minus 7.6 equals negative 4. So the operation going on right here is subtraction. And of course, the opposite or inverse operation is addition. So we're going to need to add to get rid of that, and to isolate the c, get that by itself. So let me rewrite this. C minus 7.6 equals negative 4. All right, let's go ahead and use inverse operations. We're going to add 7.6 to both sides. Remember, the reason we're doing this, we want to get rid of this to get c by itself. And that is why we're going to do this. So now make sure you're paying attention to the signs. We have negative 4 plus 7.6. So in this case, they are different signs. Remember, anytime we're adding or subtracting different signs, we subtract and keep the bigger sign. So we're going to subtract. I'm going to set this up over here, and we're going to keep the positive sign in this case since 7.6 is bigger than 4. So anytime you're adding or subtracting decimals, you want to set them up by place value. Remember, 4 would be the same as 4.0. We're going to subtract, get 6 minus 0 is 6, 7 minus 4 is 3, and our answer is going to be positive 3.6. So C equals 3.6. And don't forget, guys, we are not done yet. We're going to go ahead and check this. So 3.6 minus 7.6 equals negative 4. Remember, in this case, they're different signs, subtraction and addition. So you can go ahead and subtract, keep the bigger sign. I'm going to do it over here on the side. 7.6 minus 3.6 gives us 0, 4. So we would get negative 4 equals negative 4, which is true. So we know we got it right. All right, let's move on to another example. All right, we have negative 6p equals 48. So something I want to identify for you here is anytime a number and variable are next to each other. So when a number is next to a variable, it means multiplication. So we know the operation occurring here is multiplication. So we would have to do the opposite, which is division. So I am going to show multiplication, and I'm just going to start abbreviating. The inverse of multiplication is division. So let's go ahead and map this out again. So negative 6p equals 48. And I show these in a particular way when I'm doing it because it works that way in my brain. If it works a different way in your brain, you can do that as well. But anytime it's division, I always just put it over each other. So in this case, we want to get p by itself. So we're going to have to divide both sides by negative 6. And the reason it works best in my brain like this is because I can just cancel those out and show that p is by itself. And now over here, I'm going to divide by negative 6 as well. So remember, anytime we're dividing, we need to use, or multiplying, we need to use the rules, same signs positive, different signs negative. In this case, different signs. So our answer is going to be negative, and then 48 divided by 6 is going to give us 8. So P equals negative 8. Remember, not so fast, we're not done yet. We need to go ahead and check this. So negative 6 parentheses negative 8 equals 48. And remember, this would mean -6 times -8. A negative times a negative gives us positive, and 6 times 8 is 48. So 48 equals 48. And we can check that and know it is true because that's a true statement. And guys, anytime you would know this isn't true is if both sides weren't equal. So let's say we forgot the negative and it ended up saying 48 equals -48. 48 and -48 aren't the same, so we would know we probably made a sign mistake somewhere. Okay, let's do another example. All right, this time we see division going on with that sign. Remember, the fraction sign literally means division. And of course, the inverse of division is multiplication. So we will have to do the opposite. All right, and once again, I say I set these up certain ways because it works best in my brain. And I'm going to show you them, but if they don't work best in your brain, of course, you have the choice of setting it up a different way. All right, so we have n divided by 1.6 equals 5. So anytime it's set up like a fraction like this, I always do it like this, multiplying by 1.6 over 1. Just once again, so it can show my brain that it's canceling. So I'm multiplying both sides by 1.6 since that's the opposite of dividing by 1.6. But I always set it up like this just so I can show that I'm cross-simplifying it, that those cancel. Because some people don't understand how we get that variable by itself, and I like to show it. And then on this side, I'm going to show that it's multiplied by 1.6. And of course, we can set that up vertically if that helps as well. So I'm going to do 1.6 times 5. 5 times 6 gives me 30. 0, carry the 3. 5 times 1 gives me 5, 6, 7, 8. That would give me 8.0. Which means that n equals 8. Remember, we are not quite done. We want to actually go ahead and check our work. And you can definitely use a calculator to check your work. So in this case, I'm going to plug in the 8 divided by 1.6 equals 5. And if you want to, go ahead and pull out a calculator and make sure that's true. 8 divided by 1.6 equals, and my calculator said it equals 5, so 5 equals 5. We know that's true. All right, good job. Hopefully you are understanding this process. Remember, you are free to absolutely rewind the video or make it go in a slower speed if you need to process things a little bit slower. Let's continue. All right, so this time we have 2 steps. It's the exact same process, but remember our whole goal is to isolate the variable. So we are always going to work with the numbers outside of the variable before we move to the ones next to the variable. It wouldn't necessarily be wrong if you did it the other way around, but it definitely is harder because, for example, in this case, -6t would tell me multiplication. That means I would have to divide both whole sides by -6, which would leave me with fractions and things that I don't want to work with. So just trust me when I say work with the numbers outside of the variables first and always try to narrow down to the variable. All right, so first we're going to start with this right here, which is subtraction. We want to get rid of that -7 first. And of course, the inverse of subtraction is addition. So we're going to start with that, one step at a time. So -6t minus 7 equals 17. We're going to want to get rid of that subtraction by adding. So we're going to add 7 to both sides. Remember, -7 and +7 will cancel. And then we're going to add +7 on this side. These are both positive, so this makes the math pretty easy for us. 7 plus 7 is 14. Carry the 1, so we're left with 24. So we bring down the rest, and we are left with -6t equals 24. So now we need to ask ourselves, what operation is going on now? Remember, a previous slide told us anytime a variable is next to a number, it means multiplication. So of course, the opposite of multiplication would be division, which means we have to divide both sides by -6. So -6 over -6 would cancel to 1, so we can cross that out. And we divide this side by -6 as well. So we are left with t equals, and of course, different signs means negative. So same signs positive, different signs negative. So this would give us negative, and then 24 divided by 6 would give us 4. Plug it in, and we are all done, except we want to make sure our answer is correct. So let's go ahead and check it. So negative 6 times negative 4 minus 7 equals 17. Let's see if this is right. So negative 6 times negative 4, remember same signs gives us positive. So 6 times 4 is 24 minus 7 equals 17. And of course 24 minus 7 is 17. So 17 equals 17. We know that this is correct. We didn't make any simple mistakes anywhere. All right, there's our first two-step equation. Same process. All right, let's continue on with our examples. All right, we have another two-step here, even a little bit more challenging now with fractions. So let's go ahead and start. Okay, in this case, our variable's in the middle. It doesn't matter where it is, but remember, we're always going to work with the variable last. So the first thing we see here is negative 1/3 plus 2z equals negative 5/6. So negative would tell us minus. We want to do the opposite of subtraction, which of course is addition. So we're going to want to add 1/3 to both sides. So this is going to cancel, minus 1/3 and plus 1/3. But of course, we're going to run into a little bit of trouble here because those do not have common denominators. So we can't just add 1/3 to negative 5/6. We're going to have to get common denominators. How are we going to make 3 and 6 the same? Hopefully you are saying we're going to have to multiply it by 2. And remember, with multiplication, you could just multiply straight across. So 2 times 1 gives us 2, and 3 times 2 gives us 6. So now we have negative 5/6 plus 2/6. So remember, we have opposite signs here, which means we would subtract and keep the bigger sign. So I'm already going to put a minus in my answer. And 5 minus 2 is going to give me 3. Remember, denominators just stay the same. So negative 3/6. And of course, that would be equal to 1/2 because we divide both by 3. And when we simplify 3/6, it's equal to negative 1/2. So I'm going to reset my equation that I have right here. Those negative 1/3 canceled. So I'm left with 2z equals, and that simplified to negative 1/2. All right, so now let's do our final step. So a number next to a variable, remember, would tell us multiplication. We have to do the opposite, which is divide. All right, so we're dividing both sides by 2. And now you're running into the problem of, okay, wait, I'm dividing negative 1/2 by 2. And do you guys remember what would happen when we're dividing it by 2? So if we were dividing this by 2, that would be the same as dividing it by 2/1, right? And this is where our knowledge from last unit is so important because we're like, wait, how do we divide fractions? We forgot. Do you guys remember K, C, F? Keep, change, flip. So we would do negative 1/2, change that sign to multiplication, and then flip that last fraction to 1/2. And we just go straight across. We know different signs would give us negative. So 1 times 1 is 1. 2 times 2 is 4. We're left with C equals negative 1/4. Now don't trust me. Let's actually go ahead and check our answer and see if this is true. I'm going to put it over here this time because I ran out of room a little bit. So we are left with negative 1/3 plus 2 times negative 1/4 equals negative 5/6. So let's see if this is true. We're going to have to simplify. So we have negative 1/3 plus, let's actually multiply this. And remember, this would be the same as 2/1. So 2 times 1, first of all, we'd be given negative. 2 times 1 is 2. 1 times 4 is 4 equals negative 5/6. Once again, we're going to have to simplify. Remember, this simplifies to negative 1/2. So negative 1/3 plus negative 1/2 equals negative 5/6. And same thing, I'm still going to need common denominators. So how about we multiply this side by 2/2 and the other side by 3/3. And this one by 3/3. So I'm going to do it in my head real quick. 2 times 1 would give me negative 2/6 plus 3 times 1 would give me negative 3/6 equals negative 5/6. Of course, negative 2 plus negative 3, same signs. So that means I would add and keep the sign, would give me negative 5/6. So I know negative 5/6 equals negative 5/6. And we know that is true. Okay, so this example was a little bit more complicated. Of course, fractions make everything a little bit more complicated, but hopefully you see if you just follow the steps and process, you will be successful here. And of course, there's always that extra saving grace of checking your answer. So you can go back and say, okay, wait, I made a mistake somewhere. Where was it? Let's try this again. Okay, so I don't think I have any more examples. That is it. So hopefully you understand. For the most part, we'll be practicing so much in the next couple weeks. I'm sure you'll become a master. By now, hopefully you just have the process down, written down with some examples and maybe a basic understanding. And of course, we will build that up as we continue on these next couple weeks. All right, thank you. Make sure you keep these notes somewhere safe so you can access them.